record last lecture. I recorded it just with no sound. Isn't that cool? So let me quickly try to go over that stuff. The code is here, and kind of go over the code to have it recorded, and then we will, you guys get to ask questions or whatever. Basically, with exceptions, there is several. An exception is kind of a weird sidetracking way of controlling the flow of your program. And it's not your regular stuff. You have if statements, you have while loops, you have all of that stuff. But it's like, well, what if something goes wrong? And so the structured exception handling that Java has allows you to control certain things of when something goes wrong. And you can do several things. You can throw an exception, and that just says something went wrong. And Java does that all the time, right? The base class for most exceptions is called exception. And so there is all the things that Java directly knows that could be thrown, right? So you can throw an exception. If you know that your code may throw exceptions, you would use a try-catch block. You would do try, then put here all the code that may throw an exception, then put catch, and you can list the different exceptions that you can catch, and then what happens. Finally gets done regardless of whether there was an exception or not. So finally gets done all the time. Java requires you to specify that you may throw an exception, if your code may throw an exception. Other than the runtime exception class, which is special, they wanted to impose bondage on you, but they chickened out at the end. And so runtime exception is a subclass of exception, but if you throw subclasses of runtime exceptions, you don't have to declare them in your code. So in here we had our main, we call a may fail exception, a may fail function. This may fail may throw exceptions, and so it has to specify it here. I define my own two subclasses of exception. Actually, I define three. I define my base exception, which extends exception, so it's a kind of exception. My exception 1 extends my base exception, and my exception 2 also extends my base exception. This one can throw both my exception 1 and my exception 2. So in here, I can catch my exception 1 and my exception 2, or just catch my base exception. And since they are both subclasses of it, it will catch it. So I had code here that could throw different kinds of exception. It gets a value randomly, and then modulo 4. So what possible values can I have? You get an int and you get modulo 4. What possible values can you have? 0, 1, 2, and 3, right? Because it's the remainder when you divide by 4. So if this value is 0, I'm gonna divide by it, and so I'm gonna generate an arithmetic exception that will be caught here. If the value is 1, I will 1 or 2 or 3, I will call this may fail function. If the value was 1, it's gonna throw my exception 1. If the value is true, it's gonna throw my exception 2. And if the value is 3, then it's not gonna throw an exception. Right? So this is a horrible way of doing stuff, but if it was 0, then it will print this. if it was 1 or 2, then it will print this, and then regardless, it will print this, right? Unless it doesn't. No clue what's complaining about. I messed up my project. How? Why? Who? Let me just go to it here and remake the project. Something got messed up on the project. Hopefully this will unmessify it. Yes, reload it. Oh, nothing works. Yes. Sorry. I have different versions of Java, and Java 9 still doesn't quite work. Yes. Reload it. Yay. So now this should work. Why isn't this horrible thing going to work? Yeah. Sorry. Maybe this will work.
I think it was asking for re-importing to remove from the Eclipse.
Yes, but I have no clue how to do that in here. Ha 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 ha. Maybe one of these guys will do it.
I think in the file it is. I know about the Windows.
Yeah, and this is IntelliJ, not Eclipse.
Oh,
Can I import it? No. That is horrible. There it is. This is the main thing. Source folders is Java. Going to take it from here. Ah, maybe. Yay. Maybe. At least red stuff disappeared. How do I re-import Gradle project? There is no Gradle tool here. Window, view, tool windows, Gradle. Yay. That's the one. Sorry.
Is that the file tab?
Ah. What is this? What is this? Okay, this may allow me to do it. Use default Gradle wrapper, yes. We were just doing this on Wednesday. That is the problem with doing things live. What happened to my Gradle? Okay. Does this work? I'm gonna run it from here. We can change in build.gradle the name of the main class. So instead of caram samples hello world, I'm gonna use this guy, exceptions demo, which is in here. Okay, so we got bad math divided by 0, right? If we run it again, we're gonna hopefully get a different result. All good, finally done. We got the same, all good, finally done. Yeah. Oh, no, that should, okay. Now we got bad math. Now we got this exception, right? My exception 1. So depending on what happens, right, we define 3 of our classes which inherit from exception, right? In here, I have to declare this because they are subclasses of exception. Here the compiler is telling me, but this would also tell me. If I run it on Gradle, it tells me, right? You have an unreported exception, my exception 1 and my exception 2. If I change this and make it runtime exception, then I don't have to declare them, right? Which is still dangerous. Bad things may still happen. It's just in here, if I end up not catching, so instead of catching my base exception, I just catch my exception 1, the compiler will bug me. Well, I was saying that main throws exception. Here the compiler will bug me because I may throw my exception 2 that I'm not catching.
Why when you throw the exception, it's gonna have the error, but when you put runtime exception, it's not. It's a superclass, so.
This is Java magic. Just runtime exceptions are not checked, but exceptions are checked by the compiler. So
That doesn't make sense because it's a superclass, so it should include all the exceptions.
They made it so that the compiler knows that if you are a subclass of runtime exception, the compiler will not complain. So runtime exception is the special one.
Okay. Just runtime?
Runtime and then all of its subclasses.
But if there was another exception, it doesn't complain if you put throw exception because it's a superclass.
Wait, you can always say that you can throw exception, right? Even if you don't throw it, that's okay. If you don't say it, right, now I may throw here my exception 2 that I'm not catching here. And so this will tell me that I have to declare that I throw it. And so here, if I catch my base exception, right, or I think I can do my exception 1, my exception 2. No, that's not the right syntax, sorry. So I would need to do my base exception. Oh, and I'm rethrowing the exception, which is why I would still need to say here. If I, instead of rethrow it, I just do e.print stack trace, and life will be good. Does the idea of exceptions make sense? Yes. Reasonable sense. It will make a lot more sense once you do the assignment. We're gonna be doing that stuff also for other kinds of things. Yeah, so that's what we did last class. The other thing that we did is talked a little bit about file I/O. You basically have file input stream and file output stream, which work almost like system.in and system.out. Actually, system.out is a print writer. So once you create a print writer, you have the same as system.out. It's just a different implementation, and you can go from there. So you use the same scanner and print writer, except that you start from here. These guys have exceptions. They have runtime exceptions, but they also have file not found exception, which is a checked one. So you either have to catch it or declare it. And other than that, it's like reading from system.in and writing to system.out. Right? Make sense? Reasonable sense? Cool. Then let's start talking about unit testing. Let me make sure that this includes JUnit. How do you when you're building code, how do you know that it works? What do you do? What do you do? How do you know whether your code works or not? You run it, and then what do you do?
And when writing the code, we get a cross mark there, so we just check what is wrong there.
So you are using my unit test, but when you do code outside of my unit test or something like that, right? Or something, right? You have a test that's failing, but you think that you did the right thing. What do you do? Read the errors, but what else do you do? What do you never do anything else?
Change the code.
Change the code, okay. But how do you know what's doing? You make main call the code, right, and do something, right? Don't you do that? Yes, sometimes. Make main and see what happens, right? And then when you build the next piece, well, you change main again and see what happens, right? You exercise your code. The problem is normally you don't keep track of that. So when you're done, you delete main, right? And then next time you start debugging, you don't know what happened. Does that idea make sense? So we normally get used to, it's very good practice to have some unit tests, to have some code that just exercise your pieces, right? Your units of code, and verifies that it works. It should be, hopefully by now, Git should be second nature to you. It should each, if your code is not in a source control repository, should each if you're not using Git in all your other classes. Hopefully I can also infect you with unit testing so that it at least somewhat itches if you don't test your code at all. Maybe you cannot test everything, but so let's come up with something. We have let's call it class 2 test. Actually, I'm going to create a new package called APR17. God. Rather than having main, I'm going to do, let's do public static int, and I'm going to do a really complicated thing. Right? Really complicated stuff. Now I'm going to go write unit tests for it, right? So rather than, and this will change for us rather than put it in main, it will be in test by default. This depends on how you put this stuff. Yeah. Why aren't you creating? Why isn't this realizing that it is? So let me resync it. Oh, because this stuff is all messed up anyway, right? Create an. I'm gonna go and add a class. Add touch third main Java third test Java. I'm gonna create test1.class. test1.java, sorry. So hopefully this will create it. You can use different libraries for unit testing. One of the most common ones is JUnit. JUnit. Now there is JUnit 5, but no, we are using JUnit 4. It's org.JUnit. So we will import. All you need to do to make your test a test is declare annotated with @test. Then we can run the test, right? So when you set up your test, you can declare variables. And then what do you expect to happen? So assert is the class. I'm going to do assert equals, so we did it static. I'm going to cheat because we never talked about this. So I'm going to import this class. And so I'm going to call the method assert.assert equals. And I'm going to say, what do I expect? So when I call that add method, right, I expect to get 8. When I call so let me import this guy too. Right? What does this say? I expect that this method will return this value. I could do it without declaring the variables. There is really no good reason to declare them, but so I can do this, right? And I can have more than one test. So let's see if I do 13 plus 5. I'd expect to get 18. I expect to get 18, right?
If you don't do the code correctly, just return 8. It's gonna accept it.
Well, right. If I only have one test, right, and my code is wrong, but it passes the test, right?
Yeah.
Then that's always a possibility. So if in here I was to do grad loo it passed, right? It's horrible, it doesn't do anything useful, but it passed, right? Now what happens if I do this, right? Which is why, you need to write good unit tests, right? If I do this, now it's not going to pass, right? If you notice, I don't write terribly good unit tests. There were some pieces in your code where you wrote wrong code, but it would still work. I don't know if you ever got any of those. Like I was doing I was testing Boolean functions and I only tested for false. So if you just put return false, right, it will work or something like that. It actually requires a different kind of evilness to do. I'm recording, right? Yeah. So what would happen here? I get assertion error, expected 18, but was 8, right? So my code is wrong. So now I'm going to run it and it's going to be right? Oh, it's still wrong. What happened? You'd be surprised how many times this is exactly what happens, right? The stuff that you say, oh, this is so easy that I can do it without testing, right? And you do those things. Eventually, life is good.
Is it the same way like the grader in our assignments work?
Yes, that is exactly how the grader in the assignments works. I did some weird stuff for assigning points that is not default JUnit, so I created my own code for giving it points, but basically, yes. That is, if you did tests, you would run other stuff that had exactly this. Yes. You should get in the habit of doing this stuff for the code you write. It's probably a good idea to write unit tests for everything you write, for some values of everything. But I tend to do tons of tiny dumb mistakes that should have been caught by unit tests, because I tend to trust myself too much and not unit test the easy stuff. It's like, oh, I'll just test the complicated stuff and I'll leave all the easy stuff. And I screw up. Because, well.
So what happened for a code, very English code? For our assignment, it's just part by part, so that was a bit easy. But some codes, they are related together, many classes.
Yes.
I think it's going to be very difficult.
That is your next master's after you finish with this stuff. No. The software engineering masters, right, gets really deep into that. There's basically, actually, we can talk a little bit about testing. There is a couple of ways of subdividing testing. One is by white box versus black box. Black box testing, you don't know what the code looks like, you just know what it's supposed to do. So this is black box testing, right? Mm-hmm. I'm just saying, well, I don't know what it looks like, but it should be where's this stuff? It should be it should return 8, right? Now the other big distinction is unit testing is the simple stuff, the stuff that's individual. You can test individual units. Then there is integration testing, which is the big stuff, right? The big stuff, all the tiny pieces can be tested individually. Where you put everything together, that's called integration testing. And that usually requires a lot more tooling, right? Because it's like, well, you either test it like unit tests, usually by doing mocks. So this piece is supposed to call a server, right? So I can do two things. One is stand up a server and have it call the server and see that it works. The other one is lie to this guy, right? And stand up or cheat, and when it calls the thing that says communicate with server, I'll just have a mock implementation that always returns the same value. And then, so you can either go the way of mocking, and then it's just unit testing, right? I'm just testing this unit. when I lie to it these 7 different ways for these 7 different mocks, what comes out. The other way is integration testing. I'm going to stand up a server here, a server there, and now I'm going to do how they all interact together. And that usually requires a lot more tooling. And then there is final kind of end user testing or user acceptance testing or something like that, right? Where the end user actually looks at it, plays with it, says yes, and they give you your paycheck. A really cool thing now is with all the cloud stuff, it is relatively easy. It is much easier than before to be able to do integration testing. It's still a pain in the neck, but now you can just call AWS or Azure or whatever, right? Stand up 3 servers and script how they start and how they interact, and then do your actual integration testing, and it costs you 10 cents, which was not possible to do before. Now it's a lot easier. It's still a pain in the neck, right? Because you need to figure out which servers you stand up and how they communicate and things like that. But
I used to be an internal project auditor, so we used to look for like the test cases. So does this qualify as a unit test case?
Sorry?
Does this qualify as a unit test case?
Does this
Qualify as a unit test case?
qualify?
Can we consider this as a unit test case?
This is a unit test, yes.
Unit test case.
Read test case?
Can we consider this as a test case?
Yes, this is one. Oh, yeah. That is horrible philosophy thing. What is a test case? Right? Is this one test case or is this 3 test cases? I have no clue. I normally write my test cases like this, and I would say this is 1. Maybe this is 3. But so if you're an auditor, you would add it your audit that you have enough test cases, right? Or actually, there are code coverage tools that will check your code, run all the test cases, and then say, oh, there is these pieces of your code that you never executed. So there is something wrong with your life, which is very useful when you're doing those kinds of audits. Do test cases guarantee that you're right?
If it is like fully covered.
Can you fully cover? Right? Does this tell me, is this right? Does this tell me that my code is right? Well, what's going to happen if I get the maximum int and I add it to the maximum int? Right? What do you think is going to happen? What do I get? Some sort of overflow, right? And so, or let's do where were we? I hate this thing. If I do another really complicated stuff, what's going to happen when I divide by 0, right? Exceptions, right? So you need to start thinking about that kind of stuff when you're doing the tests, right? So can you know that it's right? Well, no. I just know that I didn't catch an error, right? What other things could go wrong? I don't know, right? So normally your test will only tell you that kind of the basic stuff works, right? There may still be bugs. It's just, there may still be errors. It's just now you guarantee that these things don't crash, right?
The only thing you could do is to give it the input and the output for testing.
for the most part, that's the basic stuff. What else would you do? Right?
If
I mean, you can do the if, right? The assertion is just this happens. So if I had a, say, a calculator class, let me get out of this so that
I mean, to make it more precise.
like, imagine that I have, public static, or actually let me do it like this. Let me not make this static. So I'll have int, sorry. Let me create a new class. Accumulator or stats calculator, right? And so what this does is I add a number to my sample, right? So now in here, I would have add test, right? Public void test. Um, C1, oh, C1 dot get. What do we expect to get before we have added a sample? 0, right? Then we can do C1 dot add. What did we call it? Just add. Why is this complaining? Oops. One. And so I can again, right, assert. Now what should be the number of samples? 2. So it can be more complicated then, right? And then assert dot assert. This is not going to work, but 1.5, right? Get average. Right? You cannot compare doubles. You need to say within. So, right? Because 1.5 is never equal to 1.5 when you have floating point numbers. Now we're saying they are within 1 over 10,000. So now this will work. So I don't know if that's what, they can be all the complicated you want. For the most part, you seldom will have if statements on your test cases because you know exactly what you're doing, right? So your test cases usually are just do this, 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 this. You could have a bunch of test cases. And let me just do this. Let me just break my test so we can also see the default stuff that happens with Gradle. Oops. Oh, I need to change the name. This fails, and it also produces a file with more detailed information. Tells me there were 3 tests, one of them was failure. You can ignore the test. Like, oh, this is failing, but I don't want to deal with it right now. I can ignore it, which is terrible. You shouldn't do it, but well. Oh, I didn't import it. So now if I was to look at my report, it would tell me there were 3 tests, 0 failures, and 1's ignored. Right? And it actually does pretty stuff. Depending on how you run your test, you get different things. If I hadn't screwed up my project, IDEA would show you all the tests that you run and those kinds of things. Same with Eclipse or wherever your IDE is, right? Does that idea make sense? Try to get used to write unit tests as much as you can. Let's start playing with something. I don't think we'll have time to, I don't think it makes sense to talk about servers and JavaScript and HTML and that kind of stuff because we don't have actually that much time. Last class was the last new material, right? Now we are basically doing more examples and just more practice, right? And then a review, and we're done. We have our final exam in like 2 weeks or so, right? So one of you actually suggested, well, since most of you will end up taking data structures, why don't we cover some of that material? You don't need to learn the data structured material. You will next semester. It's more, we'll use it as an example of what we're building, right? So let's start building, and I will keep doing this. So we'll do tests and building. We can build something that looks like an array, right? Or like an array list. So let me put it here. New class, my array list. What's the basic stuff? What does an array list do? What's kind of the essence of an array list, so we don't go build all these 700 things that it provides? Has size, get, and put, right? Actually, it's not, well, size, get, set, and add, right? So it's going to have int size, let's do for now of ints, right? Or let's do an array list of strings. So it would return a string. set index value, and then we can see ways that we could implement this stuff, right? And then void add. Does this make sense? We can start doing this stuff. Actually, we can write our first test, right? So instead of test one, let me, I still have this messed up. Test empty list has 0 size, right? So I can do my array list a1 equals new my array list. Actually, I need to include import this guy, right? So let me just cat. So that I put this guy. So this would sort of kind of work, right? Oh, that's cool, right? It's not public, so that's good. I should make it public. Should make all of these guys public, right? In fact, a lot of people promote test-driven development. You write your tests first, and so that would be the standard thing. You would write the test for a method that doesn't exist. You get a compiler error, right? Then you go implement it. And then you get green, maybe. Life is good, right? So let's go write the test. So now this should be 1, right? And what's going to happen? It fails. Life is good because I didn't implement that thing, right? So now let's go implement. And to me, that tends to happen a lot. It's like, oh, okay, so now I need to kind of implement everything together. Eventually, right? So how can I do this? And what do I, now I need to go implement stuff. How can we do this? How can we implement an array list? What's the easiest way? But what would the object contain? What data should this object contain? Right? I'm creating an object. What data should this contain? It's an array list. What's the obvious thing to put in there? int, like, how would an int help you? What do you need? What does an array list keep track of? Sorry? Array, right? You need a bunch of objects. So, well, let me create an array, right? So I'm gonna have this int, or it's an array of what? This is an array list of strings, so I need to contain a bunch of strings, right? What's a good name for this array? This is not a good name, but let me call it data. Data array sounds good to me, right? So what do I do here? Well, I need to keep track of how many elements are actually in the array, right? So I'm going to have an actual size, right? Oh, this is horrible. Yeah, let me call it actual size. How about that? Start at 0. Here, we're going to return actual size. When you add, what do we do? Data array of actual size equals s, right? Plus plus actual size, right? Life is good. So I'm going to do the same thing, right? But instead of assert is equals to 1, so I'm going to assert 1 a1.get, right? And well, it's not going to work because we haven't implemented get, right? Life is good, so what do we do here? What do we do for get? What do we return? Data array of index, right? Cool. Now let's go do stuff with exceptions. What happens if they put -1 in here? Oh, we need to start throwing exceptions, right? So what can we check? If index less than 0 or index greater than actual size, right? Let me throw a new how about we call it illegal argument exception, just because it's pretty. Yes.
Can we do it in another way, like you put public string get, throws an exception, and then put it in try catch?
Where would you put the try catch?
Inside, you cannot put it
Inside get. Well, the problem is you gave me something wrong. There is nothing that I can catch.
Put the whole get function into the try.
Whoever calls get does a try catch. I cannot, right?
Okay.
Because I don't know, right? I'm only going to throw an exception depending on what you pass to me, right? I cannot fix the problem. Basically, the idea of exceptions is that I don't know, I just know that you called me wrong. So I have to let you know that that is wrong, in a way, right? Does that idea make sense? There is no try catch. When you call it, that's when I know whether an exception would happen, and so that's where you would put a try catch, right? So this would work. Do I need to declare that I throw an exception? Well, illegal arguments exception is actually a subclass of runtime exception. So I don't really have to, right? If I was throwing something else, right, just new exception, then I need to declare it here, right? Actually, it's telling me, right, in my test, I'm calling this guy, so I need to declare it, right? So we can decide. Let me just make it runtime exception, so I don't have to do this, right? Now, how can I verify that I can throw that exception? Actually, JUnit gives you ways of doing it, but I'm not gonna do it. What happens if I do, what I want to do, right, is to verify that when I call a1.get -1, it throws an exception, right? So what can I do? Well, I can do try, do this, and then fail. Or just, no, sorry, assert.fail. And then catch yes.
A.get -1 is always an exception, so the second line never executes.
If you throw an exception, if you don't throw an exception, then the second line executes, right? That's why I'm testing that you actually threw an exception. So if I was to do this, this would work, hopefully. Oh. Oh. I'm throwing a runtime exception in here, not an illegal argument exception. So that's good. I actually caught an error, right? I was saying that it has to throw an illegal arguments exception, and that's not true, right? That's not what it was doing. Now this would work. Except if I wasn't throwing this stuff, right? Actually, I have no clue what would this throw. Maybe it would actually throw an illegal argument exception anyway. No. Throw an array index out of bounds exception. So now it failed, right? I do this, now it's right. I probably want to test.
You put the thing that possibly can throw an exception in the try, but here you put a line that always puts an exception.
Well, I'm verifying that it actually throws an exception, right? If you did the code wrong, then it won't throw an exception, and so my test will fail. Does that make sense? I'm actually testing that it does throw the exception. Cool. And this is about done for time. Yeah.